Well, welcome to this online revision session for AQA FP4, in which we'll be doing the January 2010 question 3 on vector geometry. You can see this question is to do with a plane, or planes in general. First part, we're given the vector which is perpendicular to the plane, in other words the normal, and a point that the plane actually contains, point A, and from that we need to determine the vector equation of the plane. From there we then are given a second plane and we're asked to find the angle between those two planes, which is very much of a standard method that we should know. Well, in the first part of the question then, we're given a vector which is perpendicular, which as we said is the normal to the plane. We're given a single point A which is on the plane, and we know that the form of the equation is then r dot n equals d. So r we know is any point on the line for its position vector, which is going to be x, y, z. And so when that is dotted with the normal, which is 9, negative 8, 72, that must equal some value d. Now if that's true for all values of d, for all points, then it's true for a particular point. So to determine the value of d, we now substitute in 2, 10, 1 into this. And if we do that, we've obviously then got, when we do the dot product, 2 times 9, 10 times negative 8, 1 times 72. And if you add that all up, we will end up with d being equal to 10. And so our equation then becomes that this must equal 10. Okay, so there is our equation in the form that we require. Okay, marks for that, well it's 3 marks. So 1 for clearly identifying the normal will be the first issue. Then using the appropriate form of the vector equation will be 1 mark, and obtaining the correct value for d will give you your 3rd mark in here. Moving on to the second part then, we know from our 2 equations then, we have the normals for both of these planes, because we know one normal, n1 is 9, negative 8, 72, and the other normal is 1, 1, 1. And we know then to find the angle between the planes, well we need to find the angle between the normals up here. And we know whatever that angle is in here, this angle down here is 180 minus that value, or the acute angle could be the one that's out here. So either of these two might be the one that we require. It will all depend on what value of theta we come up with, but we need an acute angle. So we know that the cosine has got to be positive to give us that acute angle. So where do we go? Well, let's write down what the normals are then. We've got the normal n1 will be equal to 9, negative 8, 72. We know the second normal is just 1, 1, 1. Then, having got those two, we then know that to get this angle, we know that if you take the vector n1 and dot it with n2, it's equal to the length of n1 times the length of n2 times the cosine of the angle between them. So we know that the cosine of the angle between them is going to be equal to n1 dotted with n2, that's the vector product, divided by the length of n1 and the length of n2. So what do we need? Well, let's firstly work out the lengths of these vectors. So the length of n1 is going to be the square root of 81 plus 64 plus 72 squared. I'm just going to write 72 squared at this point, and then I'll throw all of that into my calculator, I think, or to get the value for that. So that is actually equal to the square root of 15,987, which actually is equal to 73 multiplied by root 3. It will actually, you can take out a square factor there of 73 squared. Okay, which is quite handy. Similarly then for n2, that's the easy one, it's just going to become square root of 1 squared plus 1 squared plus 1 squared, which will just be root 3. So that's quite handy. Okay, because what have we now got? Well, if we do the scalar product, we got 1 times 9, 1 times negative 8, and 1 times 72. 72, and then the 9 makes 81, and we take away the 8, and that makes 73 on top. And then on the bottom, we are going to have what value? Well, it's going to be 73 multiplied by root 3, because I think, let me just check a moment. We check on our calculator there the value of the length of n1 for a moment. Yep, sorry, I made a mistake then when I was writing that down. The n1 here, this square root, when you've checked it on your calculator, that is just 73, not multiplied by the root of 3. Okay, so yeah, this is just 73 then is the n1 dot n2, and then the n1 times n2 is 73 multiplied by the root of 3. And so this cancels down to 1 over root 3. And that is an appropriate value for the cosine of an acute angle because it's between 0 and 1. Okay, so from our diagram, we're quite happy that that is the correct value for the cos of theta. Well, as to where the marks go, we can see that there are 4 marks for this part. So a method mark for knowing how to find the cosine of an angle from the scalar product, or obtaining the 73 on the top from the scalar product, calculating that part, you get 1 mark. And similarly for the denominator from the 73 and the root 73, you'll get a mark for that. And then finally for obtaining the 1 over root 3 as the correct answer at the end, you will get 1 mark for that one as well. Well, hopefully you found that solution helpful. My apologies for the small error in there. Please go to the Further Maths Support Programme website for more help with your further maths revision.